Hello and welcome to our math series. I want to believe that you've been taking up a whole lot of exercises and doing lots of work. Well done. Length of arc of a circle. What actually is the length of arc of a circle? Now you look at the circle below, you notice there is a green portion of the circumference and there is the red portion of the circumference. The green portion is the major arc, while the red portion is the minor arc. You following, right? Okay, we also have the radius. Now there are two, so we call them radii. Notice that the radii has cut the circumference of the circle in two parts. So these two parts are now what we call major and the minor arc. So if we're putting that in a sentence, we say an arc is a portion of the circumference of the circle that has been cut off from a part of that circle by two radii or by a chord. If we are determining the length of an arc of a circle, there are two basic requirements that are necessary. Number one is the radius of the circle, and number two is the angle theta. Remember, this angle is always between the two radii, which cut off the arc from the circumference of the circle. Also note that since the value of theta may change depending on the movement of one of the two radii, then the length of an arc of a circle is at all times proportional to the value of the angle subtended by the arc itself. In simple terms, when theta increases, the length of the arc also increases. So the bigger the angle, the longer the length of the arc. So I want you to take note of that. It's very important. Hence, a circle with center O, radius r, and angle theta subtended at the center will have length of arc to be equal to theta over 360 multiplied by 2 pi r. In simple terms, the length of arc is actually the ratio of angle subtended at the center multiplied by the circumference. 2 pi r is actually the circumference, so we multiply that by the ratio of the angle. That is how we get the length of arc. That's quite simple. So here's an example. It says, find the length of an arc of a circle with radius 7 cm, which subtends an angle 84 degrees at the center of the circle. Given that the radius is 7, theta is 84, and pi is 22 over 7, we simply substitute the values into the formula. So where we have theta, we simply put 84 degrees. And where we have pi, we simply substitute 22 over 7. Where we have r, we substitute 7 cm. So by the time we do that, we'd have 84 over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 7. Doing the maths very carefully, we're going to have 25872 divided by 2520. When you punch that on the calculator, you would have 10.26666 cm. So we actually approximated that to 10.3 cm. You can try this work at home. It says if an arc of a circle radius 13 cm subtends angle 105 degrees at the center, calculate the length of the arc. So you can follow the example that we just finished and ensure that you turn in your answers as soon as possible. I'll be waiting.